Now, I said this in my last video, but only one-to-one functions have inverses. And the reason that's the case is, like, say we're imagining a function which is not one-to-one. Again, I'll return back to the World Series example, where, I had a case, where in 2012, the Giants won the World Series. And then in 2014, they won again. And then, whatever else. Again, I don't remember all the teams in particular, but let's just say in 2013, the Padres won. I know that's not the case, but just making up some thing because I don't remember off the top of my head who won in every single year. But anyways, so why is that a problem? So basically, again, this would be an example of a function which is not one-to-one because I have two different inputs with the same output. That's fine in a function, but not fine in a one-to-one function. But let's say I was to try to find a function inverse. Now, the inverse function is a very simple idea. Basically, it's a function where you're going to switch the domain and range of the function, but keep it the same. Keep all the correspondence the same. Because again, we have a domain, we have a range. But if I were to reverse the arrows in my graph, basically that would kind of change them to go this direction instead. That would be the idea of an inverse function. So basically, the range would become the new domain of my inverse function, and the domain would become the range of my inverse function. And that's basically it. It's a pretty simple idea, and it's quite important. We'll talk about some of the uses as we progress through the chapter. We will first focus on how to find the inverses, which in some cases can be a little bit more complicated. And in class this week, I'll get into some more situations where the algebra is a little harder. But basically, so why is not being one-to-one a problem? That's what I wanted to address. Because in the last video, I said if it's not one-to-one, it can't have an inverse. But if we look at this example, this one was not one-to-one. And the reason why this one, we would say it is not an invertible function, is because when I invert it, notice what happens is the Giants is now connected to both 2012 and 2014. And if you recall back to the original thing with functions, is the one condition for a function is that for each input there can't be multiple outputs. It has to be predictable. We always need to know the answer, and there can only be one answer to a function. It could be possible that we don't know the output and we'd say that that's not part of the domain, but this is a contradiction to a mathematical function. The Giants can't have more than one answer, because in a function we always have to say, well, if this is the input, what is the output? And if I ask you, well, in what year did the Giants win the World Series? There is not one answer. There's multiple answers. And again, that is not a function. A function always has to have a single predictable answer. So that's exactly why this function is not invertible. Because if I try to invert it, I get a non-function. Hence, it doesn't have a function inverse. And that's kind of the whole reason. So, sort of summarizing, if a function is not one-to-one, it will not be invertible. And we don't need to bother trying to find the inverse. Now, there are certain mathematical tricks to get around not being one-to-one, but that's sort of the summary to begin with, is that only one-to-one functions are invertible. Let me go ahead and write that out in the packet for today. Only one-to-one functions are invertible. Now, how do we actually find them? And so this is built on, there's a particular set of steps, which depending on the textbook that we're using, because I've used a lot of different textbooks to teach this, and some of them have the steps in a slightly different order, but I'm just going to use the ones in the packet because I'm used to it, because I think it makes more sense to do it this way. But anyways, let's kind of walk through the steps and look and do a couple examples. So basically, step one, it says to make sure your function is invertible. Step two, and so we would check the horizontal line test in order to do that. Check to make sure it is one-to-one. And if it is one-to-one, we're good to go. Step two, it says to write y is equal to f of x and interchange x and y. So let's go ahead and do it for the first example below. Basically what it's saying to do is I'm going to switch f of x to y and just rewrite it, instead of as a function notation, use our basic equation notation x and y for our variables. And then what it says to do is interchange x and y. And that's kind of a weird thing in math. We don't really usually want to do this, but we're actually going to switch the locations, basically change all the x's to y's and all the y's to x's. Now, this is kind of a weird step, but this step 2 is exactly when we're inverting our equation, because this equation describes a correspondence between x and y. Or if you're thinking about a domain and range, x is our domain, y is our range. If we want to keep the relationship exactly the same, but we want to reverse the domain and range, kind of as I was saying over here, that's kind of the idea of an inverse function, swapping the domain and range. If we just switch x and y, that is exactly what would happen, right? We would change which one is the element of the range and which one's the element of the domain, and it would still be mathematically defined in the same way. So basically, inverting an equation is as simple as interchanging x and y. That's literally it, and this is now the inverse equation. Now, however, to get it as an inverse function, we want it to be in function form or solve for y, right? Because a function is always solve for the y variable, and that is what step 3 says to do. It says to solve for y, the resulting equation you're going to have is y is equal to your function inverse. And the reason why I'm getting into all of these y's is because I remember learning this, in high school or whenever, and I could do it, I could find the inverse, but I didn't really understand it. And that's kind of that's really why I'm getting into all this in the videos, is it really makes sense, because you're just taking your equation, you're switching x and y, that's inverting it, and then we're solving for y, because functions are always solved for y. So to me, it just sort of makes sense. And memorizing these steps is a little bit weird and might be hard to remember on a test where you didn't have it, the steps with you. But for me, it's something that I don't need to memorize these steps, because it just makes basic sense. But anyways, to solve for y, we could subtract 5 to the other side. Actually, and I'll switch the sides of the equation that I have, and then divide by 4. So y is equal to x minus 5 over 4. I could distribute that 1/4 to each term, but I'll just go ahead and leave it like this, since it's not too specific. Oh, and then the last step is then this would be, the resulting equation is y is equal to the inverse. So basically, you could then replace the new y with f inverse, and this would be my inverse function. And the thing about an inverse function is it's going to be, it's going to have properly, it's going to still be an inverse function, but since I've switched x and y, the meaning of these is different, because x here was the original domain and the output provided the range. Well, now we're changing, but basically, one thing that can be confusing is, well, x is going to be the same in either case. It's the same variable. But remember, x is just a random letter that we use for the input of a function. It doesn't always correspond to domain. Like in an inverse function, it would correspond to the range of the original. But we'd still say that it would have a new domain and a new range, because it's an entirely new function. But it obviously is related back to the original in that it is exactly opposite. In the next video, I'll do another example, and I'll talk a little bit more about how we can use inverse functions, mathematically speaking. And we'll actually continue this more in class this week.